Hello friends, my name is Kisan and welcome you in this video tutorial. In this video tutorial we are going to discuss about the sum of the concurrency improvement in Java 8. So here is the Google. Let's try to search by typing Java 8 concurrency improvement, and here we get the Oracle official website. So let's click over here, and here I'm talking about this section of improvement, saying that new methods in java.util.concurrent.ForkJoinPool. So this is basically a class which belongs to this package. If you go to the JDK, this class basically has been added in JDK 1.7. so this class is called ForkJoinPool. Now a new method has been added in this class. It's called common pool. So if you press Ctrl O and try to search a common pool, so this method was added in JDK 1.8, and there is one more method which was added in. If you go to the top of this class and try to search by typing, go to the top of this class and try to search by typing 1.8. so saying that this common pool was added in JDK 1.8, and again there is another method is called get common parallelism. Get common pool parallelism. This was added in JDK 1.8. So these were the two methods has been added in JDK 1.8. So you can see the description saying that a static common pool method is now available and appropriate for most applications. The common pool is used by the fork join task that is not explicitly submitted to the common pool. Using the common pool normally reduces the resource usage, right? Two new methods like get common pool parallelism and common pool have been added, which returns the targeted parallelism level of the common pool and common pool instance. So basically common pool, this will return you the targeted parallelism level of the common pool, and common pool method which returns the instance of fork join pool. So first of all, let's try to understand how fork join pool works. So here I have a slide. Let's go through this slide and try to understand how basically fork join pool works. So when we talk about the fork join pool, the common fork join pool was introduced in Java 8 to support parallel stream. So just few minutes ago I have shown you a method is common pool, right, that returns you the fork join pool instance. Now the common fork join pool was introduced in Java 8 to support parallel streams, completable, future, etc. So we had seen what's the use case of completable future in previous few video tutorials, right? Now fork join is based on the parallel computing, where a problem gets divided into sub problems until the sub problems are simple enough to solve simultaneously in the separate threads, after which the results are aggregated, right? So basically a big problem is divided into the small problems, and you get the aggregate result of all small problems, and that would be the result of the final task, right? So the algorithm that's been used in the fork join implementation is the work stealing algorithm to ensure that no CPU is idle. Now let's take a look at how work stealing algorithms works. Suppose there are 4 processors on your system and task T has been divided into 12 subtasks as you can see in this picture. So suppose you have a task from T1 to till T12. So suppose task T is bigger task and that has been divided into 12 tasks, right? So task 1, task 2, task 3, which is assigned to the processor 1, and task 4 to task 6 assigned to the processor 2. Similarly, task 10 to 12 is assigned to the task processor 4, right? So the below snapshot depicts the fork join process, right? So here you can see in this picture, suppose suppose each processor has 3 subtasks, but suppose processor 3, here you have a processor 3 is too busy with work and processor 2 is idle. It either finished all the tasks or it's in a waiting state. Then processor 2 will ask to the processor 3 if it needs help and takes a percentage of the tasks. So processor 2 will ask to the processor 3 if it needs help and takes the percentage of the task. So processor 2 is stealing the work from processor 3, right? So as I have shown in this picture, right? Now let's look at the snapshot below to understand the fork join framework. So here I have written the algorithm saying that create subtask for task T, which is a bigger task. If task T is big, then what we are trying to do, we are just breaking subtask into different small tasks, and just we are calling create subtask recursively, and we get the aggregate result as a result, which will be the result of task T. So that has been shown in this algorithm. Now in this picture you can see that we have a task T. In beginning, task T is divided into task T1 and T2. Now again task T2 is divided into 2 subtasks, task T3 and T4. And finally, if you sum of the result of task T1, T2 and T3, that would be the result of task T. So here I have written in description, task T got finally divided in 3 simple subtasks T1, T3 and T4. T1, T3 and T4. This is shown as a fork, and this is called as a fork. Now result of T1 plus result of T3 plus result of T1 plus result of T3 plus result of T4 equals result of T, and it's known as join. So this is known as join, that is have been shown in the figure, and this is called fork. Task divided into the subtask is called fork, and you get the aggregation of result subtask is that is called join. Now we can create instance of fork join pool by calling its constructor, and this constructor accepts a integer argument, that is nothing but the parallelism. Here parallelism is the target parallelism level, or you can say number of processor, which can be calculated as below code snippet. So you have a runtime class, and runtime has a factory method is called get runtime, which returns the instance of runtime. After that you can make call to the method is called available processors. This will give you the currently available processor in your computer. To support parallelism for collection using parallel stream, a common fork join pool is used internally. Okay, so in a lot of collection method supports parallelism, and this parallelism has been achieved through fork join pool itself. We can get a common pool using the fork join static method. So I have already shown you in fork join pool we have a static method, which is addition in the Java 8. So this is a static method, so directly you can call by class name like fork join pool dot common pool, and this will return you the instance of fork join pool itself. To see the parallelism for this common pool, so here you got the common pool, right, that is instance of fork join pool. If you want to check the parallelism, so you can call common pool and dot get parallelism, right? So this will give you the parallelism level. So this will return you basically integer, and that will show you how many core has been used in your computer. So that's the thing. So if you can see, like get parallelism, right? So this is a method which returns the integer, returns the targeted parallelism level of this pool, right? So I hope you understood how fork join pool works. In next video tutorial we'll see a hands-on example on how we can work with common pool, right? So till that, thanks for watching this video and see you in next video tutorial.